In this video, we're going to look at different types of reactions. So in class, we're learning how to balance chemical equations, and there's many different types of chemical reactions, and we're going to go over a few of the kind of broad general types of reactions. So the first being an acid-base reaction. So in an acid-base reaction, an acid reacts with a base. So we'll use HCl aqueous plus NaOH aqueous. So HCl is my acid and NaOH is my base. And in an acid-base reaction, the products are going to be water and a salt. So my salt will be NaCl aqueous. So the water comes from the H on the acid and the OH on the base. And let me change colors again here. And then my NaCl will come from the Cl on the acid and the Na on the H. So get water and a salt being a metal and a nonmetal with opposite charges, so a cation and an anion. Another type of reaction is a precipitation reaction. And in a precipitation reaction, ions swap. Your book calls it a double replacement reaction. So let's say that we have two equivalents of sodium hydroxide aqueous reacting with copper sulfate aqueous. Okay, and we want to know what's going to happen to the products there. So we have cations here, right? So we have sodium and we have copper, and then we have anions here. So what's going to happen is those two cations are going to swap places to make the products there. And so that's what your book calls a double replacement reaction. So I'll move this table over here and say double replacement. I just think of it as an ion swap. So what happens then when we look at the products is we're going to have, let's see, I'm going to put my products in blue so we can tell what's going on here. So if we think about the charges associated with these guys, right, the sodium has got a +1 charge, the hydroxide has got a -1 charge, sulfate is -2, so copper must be +2. So the product is going to be copper hydroxide, and we don't know yet if that's a solid or a liquid. We're going to have to look it up, plus sodium sulfate. So the copper being +2 has to have two hydroxides with it in the product, and the sodium being +1, there has to be two of them with the sulfate, since the sulfate is a -2 compound. So now what we're going to do is look at this table over here, the solubilities table, and that's going to tell us if we have a precipitate or not. So we'll go down and look. So we can see here insoluble compounds and soluble compounds and the exceptions. So soluble compounds, and we're going to look right here first. Okay, so compounds containing the alkali metals, and so ours contains sodium, and there's no exceptions to that rule. So that tells us that this compound, sodium sulfate, must be aqueous. It's not a solid, okay, because all of those compounds that contain sodium are going to be soluble. Then if we look on the other side, we're just going to look for one of the compounds that's in there. So we got copper and hydroxide, and if we look down, we can see that the hydroxides are right here, and that those are insoluble compounds, with the exceptions of the alkali metals, which would be sodium, lithium, potassium, and then also barium. Well, so this guy is paired, this hydroxide is paired with copper, and that's not on the exception, so that must be insoluble. So that's going to be a solid. So this is a precipitation reaction because a solid is formed. And we can use a table like this to predict what the products are going to be. So you take your cations, you swap them to see the possible products, and then you look to see if the products are soluble or not. You guys will be doing this in lab this week, so it'll be a nice kind of hands-on experience of when a precipitate forms, and you're going to use known compounds to determine what the unknown compounds are. We can also look at combustion reactions, and this is basically when we burn anything in the presence of oxygen. A common combustion reaction is the combustion of a hydrocarbon, which is a compound that contains just carbon and hydrogen in the presence of oxygen. So methane is an example. So we use that as natural gas to heat our homes. We can burn that in the presence of oxygen, and that will give us CO2 gas, and because we're burning it, H2O in the gas phase. So we use methane to heat our homes. The release of heat is also formed from this reaction, and the byproducts are water, which is not so bad, and then methane, which is a greenhouse gas. This reaction can also be categorized as an oxidation reaction, because in the products here you see that I am adding oxygen to these compounds. So it started out as just carbon bonded to hydrogens, and then I have carbon bonded to oxygen and hydrogen bonded to oxygen. So the simple way to recognize an oxidation reaction is when atoms have oxygen added to them over the course of the reaction. Generically speaking, we would call this methane a hydrocarbon because it is made of only C and H. So we say CHXY. So that's the generic formula for a hydrocarbon. So you can actually burn a lot of things in oxygen, but all of our fossil fuels are hydrocarbons, so different lengths of carbon-hydrogen chains that we burn in the presence of oxygen to get that byproduct of heat when it comes to our houses or energy to make our cars run.